Welcome to our AERO 302 flow visualization presentation by Andrew, Bryce, Daniel, Skylar, and Alex.
To turn on the water tunnel, we first plugged in the power cables, turned on the computer, and flipped the gray switch. The pump was started and set to a constant frequency of 15 Hertz for the experiment. For dye injection, we opened the shop air valve and adjusted the pressure regulators for smooth dye flow through the blue and green ports. Then, the cylinders were set up by placing them in the test section, positioning them behind the dye tube for vortex visualization.
At low Reynolds numbers, flow will separate at low angles from the rear of the cylinder. This is due to high viscous forces, which tend to keep the flow attached. As the Reynolds number increases, the angle of separation tends to increase. At this point, regular vortex shedding can be observed.
For flow over cylinders at high Reynolds numbers, the flow separates about 90 or 60 degrees from the back of the cylinder. That would create these vortices, which detach from the cylinder because the inertia of the flow, which is higher than the viscous forces of the flow. And these are usually traveling at the back of the cylinder, about 0.5 to 0.8 times the speed of the free stream.
Here we can see through these videos what Skylar and Alex were talking about by looking at the recordings from the lab of all 6 diameters that were being tested. The flow is moving across with the blue dye and the green dye being on separate sides of the cylinder that we placed in the tunnel. And we can see that as the cylinder increases, the size and distance between vortices also increases, which will directly impact the frequency.
The Reynolds and Stroh-Hall numbers for each cylinder were calculated using the free stream conditions of the water, the shedding frequency, and the diameter as the characteristic length. The Reynolds number versus Stroh-Hall number plot shows a positive correlation. This was what we expected to see because the lower Reynolds number flow stays attached to the cylinder for longer, resulting in less frequent vortex shedding.